Hi, everybody. Happy Thursday. Hopefully, I'll see some of you in class today. So, we are going to continue with talking about the biogeochemical cycles, and we're going to be talking about the carbon cycle today. Well, actually, we're going to be talking mainly about the water cycle, but you'll be doing work about the carbon cycle. So, yes, you are a part of the carbon cycle. So we are carbon-based beings. Most of our body is made up of some form of carbon. And so you are part of the carbon cycle. And the carbon that makes you up, pretty crazily enough, could have been in a dinosaur at one point. Because remember, matter cycles. And mind blown, the stuff that makes you up probably made up like old dinosaurs. You could have been a T-Rex at one point. Like your atoms could have been in a T-Rex. Like, mind blown. Pretty crazy. All right, so quick review. Antoine Lavoisier said matter cannot be created nor destroyed. This is the law of conservation of mass or law of conservation of matter. This is why we have nutrient cycles in the first place. As we said yesterday, Mufasa said this, I think a little more eloquently, we are all connected in the great circle of life. And that connection is the matter cycles, biogeochemical cycles. So, quick review of words, reservoirs. These are pools that contain the chemicals. So for carbon, a great example would be our atmosphere, which contains carbon dioxide. It stores a lot of carbon in the atmosphere. And there are two different types of reservoirs. We have sources and sinks. A source is, you can kind of think of it as a reservoir that emits a lot of that chemical. So for example, a source of carbon is going to be cars burning fossil fuels, right? That emits a lot of carbon dioxide. It's a source of carbon dioxide. A sink is you can kind of think of it as like a storage container. It stores a lot of the chemical that we're talking about. So for the carbon cycle, one of the largest sinks of carbon is actually our ocean. Our oceans have a lot of carbon dioxide in them. And then flux is the arrows. All right, so that's the movement of the chemical from one reservoir to another. So every time I exhale, all right, carbon dioxide is going from inside of me into the atmosphere. So there would be a flux arrow going from me to the atmosphere. Residence time is how long a chemical is stored in a reservoir. All right, so what is cycle boogie? Let's talk about it. So most of our water is stored in the ocean. This is a big sink for water. Of the water on the earth, like I said, most is in the ocean. Of the fresh water, most of our fresh water is stored in ice caps and glaciers. And then the little baby tiny bit that's left is going to be stored in our rivers and our groundwater. So there's also some water in the soil that will eventually get into the groundwater. We don't really use soil water. Typically plants will use this, and once it kind of leaches through the soil into the groundwater, then we can use it. We also do have some in our atmosphere, but the atmosphere is not considered a sink for water. Water does not stay very long in our atmosphere. It rains. All right. So these flux arrows, so the most common you will see, there's evaporation. That's how most of the water gets from the oceans, even the rivers and lakes really, into the atmosphere. And then once it's in the atmosphere, so remember, evaporation is driven by the sun, heats up the water, turns it into its gaseous state, and it rises through the air. Once it gets up in the atmosphere, it's so cold that that gaseous water condenses into a liquid and rains down as precipitation. It could also condense into a solid and then come down as snow. Once it falls and it's in the soil, All right, we have two options. Part of that water is going to go into our groundwater. The other part is going to go into land plants. Plants need water to grow. They use their roots, they suck it up. Any extra water is going to be lost back to the environment through transpiration. All right, so transpiration is like kind of like plant sweat. Good way to think about that. Basically, the leaves of plants have these little pores, and the sun, again, causes water to evaporate, but when it comes from a plant, it's called transpiration. So, humans, runoff. So, when it rains as well, so it's raining, it's raining, it's raining. If that rain lands here, all right, it's going to flow into the nearest river or lake, and that's called runoff, is when it flows over land. Okay, I think I've gotten everything. That was in the water cycle. So now I want you in the comments section of this YouTube video, or you could do it, I guess, on Google Classroom. I want you to answer, how do you think humans have affected the water cycle? Press pause and answer. All right, hopefully you press paused and hopefully you answered. So we have affected the water cycle through our extraction, definitely, of groundwater. So we are extracting groundwater at faster rates than it can be replenished, which is not good in places where there's already drought, like out in California, and even just out west. One of the largest groundwater resources is almost entirely gone because we're extracting so much water at such a fast rate. Another way that we affect the water cycle, you wouldn't think of this, but we like to cover the ground in a lot of impervious surfaces, things where water can't run through. So concrete, asphalt, all of the stuff that we like to put on top of the dirt to stop us from stepping in the dirt, it prevents that water from getting into the soil. So instead of the water going into the soil, what you have is like an impervious hard surface, and the water just bounces off and runs off either into sewers or into rivers, streams, and lakes, which is also causing our groundwater resources to diminish. They are making, kind of cool, concrete that absorbs water and actually lets the water get into the soil. So we'll talk more about impervious surfaces and kind of the effects of those later on, but those are just two ways. All right. So this, I want you to just like think in your head. You don't have to answer anywhere. This is an example of an AP question. What part of the water cycle do you think is the most affected by impervious surfaces such as asphalt and concrete? Is it A, evaporation, precipitation, groundwater flow, or runoff? So you're just thinking it in your head. Have you thought of it? Have you? All right, so the answer is D, runoff. It increases the amount of runoff into rivers, lakes, and streams because the soil can't absorb it. So instead it's running off into other places. All right, so you are going to go to your interactive notebook and you're going to construct the great circle of life by reading the passage and filling in the diagram with reservoir names and flux arrows. So you're doing this for the carbon cycle. Tomorrow we'll go over the carbon cycle together. Hint, bolded words are the carbon reservoirs, italics are the flux arrows. And look at this funny conversation over here. Hey man, what's up? Just converting oxygen into carbon dioxide. You know, the huge. WTF, man. School's out. Why are you still doing science? Breathing, Jake. I'm breathing. You all do this every day. You're all part of the carbon cycle. All right, so let's look at our interactive notebook. All right, so here is the carbon cycle. I'm doing the same thing really you did yesterday. I have a word bank of all of the reservoirs and of all of the flux arrows. You're just going to click here, type it in. Black, remember, are the reservoirs. Red are the flux arrows. That's all you have to do today is do the carbon cycle. The reading is on the first page. Just click it. It'll take you to a passage. You can use that to complete the carbon cycle. If you have questions, office hours every day, 2 to 2:20. I will be there, or I will be square. I will see some of you in class. All right, bye everyone. Maybe.